How many of you have tried the first problem? This is the first problem, right?
Yes, sir.
Okay. So the properties of copper were not given, right, in the question. You are supposed to take it from the heat and mass transfer data book.
Yes, sir.
How many of you have searched? How many of you have a heat and mass transfer data book with you now? I mean now for this class. So hereafter, please uh, get hidden mass transfer data book and bring it to the class, especially during the class hours. You try to have it with you. Okay, is it fine?
Yes, sir.
Because
Yes,
even
sir.
in the cat one questions, even in the cat one, you are supposed to use the hidden mass transfer data book to get the properties of copper. I won't give you the properties of copper. You are supposed to get it. Okay. Now, uh, what is the property of copper? See, actually, first, what is the thing which, whenever a problem is given in unsteady state, what is the first thing we have to do? We have to check the Bayes number, right? No, excuse me. We have to check the Bayes number. Am I correct?
Yes, sir.
Okay. Now, before getting the Bayes number, uh, get me the properties of copper density from the data book. Row value, density, CP value. It will be in page number 2 or page number 3 of your data book. Properties of metals, thermal conductivity, density, and specific capacity. Please tell me the values. Students, can somebody can show it in the. Can you? Yeah, Dinesh Balaji, what's the problem you have? Dinesh?
Nothing, sir. Nothing, sir.
Yeah.
Sir,
Can
density of copper is 8,954.
Okay, ma. The person who is saying it, Ramkishan, can you switch on your webcam and can you show it to others? Which page it is? Ramkishan?
Two, sir.
Yes, sir.
Yeah, yeah. HMD data book you have? Yeah. Uh, which page number it is?
Page 2.
Page 2. Okay. In page number 2, you have this density. What copper? For copper, pure copper you can take. Copper pure is given, right? For pure copper you
Yes,
can
sir.
take. Okay, ma. Okay, fine. You can switch off. You can switch off. Now tell me the density, specific capacity, and thermal conductivity values.
Sir, specific heat is 383
383. What is the unit? Joule or kilojoule?
joule per kilogram Kelvin.
Joule per kg Kelvin. Okay. And
And
what about density?
density is 8,954 kilogram per meter cube.
8954. Okay. Kg per meter cube. And what about thermal conductivity?
386 W per mk.
386 watt per meter Kelvin. Okay. Don't say W by MK. Okay. Watt per meter Kelvin. Okay. Fine.
Yes.
Fine, students. Okay. Now going back to the expression which we have. Okay. Going back to the expression which we have. What is the basic expression? First one is Bayes number. Bayes number is HL by K. Right? Bayes number is HL by K. So we have to check the Bayes number is less than zero point 0.1 HLC divided by K. That is characteristic length. Okay. And often for copper plates or a thick plate and all, we know that L suffix C is equal to thickness divided by 2. Am I correct? So 6.25 divided by 2. How much it is? How much?
3.126.
3.125.
123 into 10 power minus years. Am I correct? Is it fine? Is it visible?
Yes.
Yes, sir.
Is it visible? Okay. Now, checking out Bayes number. Bayes number is equal to HL by K. So the conductive heat transfer coefficient of the uh, plate with the surrounding fluid is given as 90. Okay. So 90 into 3.125. All of you are able to follow this?
Yes, sir.
And thermal
Yes.
conductivity from the HMT data book, how much we got? 386. Is it correct?
Yes, sir.
So what is the Bayes number we have?
Uh, Sir, it's 7.2 into 10 power negative 4.
7.2 into 10 power
10 power negative 4.
minus 4. Okay. So it's a dimensionless number again, HLC by K. So which is less than 0.1. So we have to assume lumped parameter system. Is it fine?
Yes,
Yes,
sir.
sir.
So the heat solid is assumed to be a one lump which is dropped into a fluid which is at a higher temperature or lower temperature. Okay. Lumped parameter system. Okay. Now we know that what is the expression? T minus T infinity divided by T naught minus T infinity, which is equal to e power minus, what is the formula ma? HA by rho Vc.
Yes, sir.
HA divided by rho Vc into
Into T.
tau. T or tau? Small t or tau?
Tau.
In data book which is given, T is given or tau
Tau.
is given?
Tau. Tau.
Tau. Okay. So the tau is the time seconds. Okay. Now look into the problem. This is the expression. Now what they are asking is uh, uniform temperature 300 degrees C. Okay. Initial temperature is 300 degrees C. It is suddenly lower to final temperature is 36 degree. Calculate the time required for the plate to reach 108 degrees. Okay. So here final temperature is 36. Initial temperature is 300. What is the time taken for time taken for the plate to reach 108 degrees? So here T equal to 108 degrees. Okay. And T naught is nothing but the initial temperature, which is nothing but the 300 degrees, and T infinity surrounding fluid temperature is at 30 degrees. Sorry, 36 degrees. Am I correct?
Yes, sir.
Is it correct or not, ma?
Yes, sir.
Everyone.
Yes, sir.
Yes, sir.
It's 36.
Uh, all the values here, okay, and get me the answer. Ravi, please take it down. Substitute everything and get me the answer. All of you have taken down this expression? Students?
Yes, sir.
All of you?
Yes, sir.
Okay. Now let me write it here. H value is 386. Sorry, H value is 90. I'm sorry. H value is 90. K value is 386. Okay. So now I have the liberty to write E by A, which is equal to L suffix C. Okay, so which implies A by V is equal to 1 by LC. Am I correct?
Yes,
Am I
sir.
correct, students?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
So, like that, you can substitute here. Okay, so E power minus H. H is 90, it is given. E power minus 90 into tau divided by what are the other things? The denominator rho VC. Okay, rho LC. Okay, rho density is what is density? 8954 and 383. 8954 8954 into 383 into 1 by L suffix C. So what is the L suffix C value? Thickness divided by 2. 3.125 into 10 power minus 3, right?
Yes, sir.
Yes, sir.
Okay, substitute it here. Students, all of you are able to get how I am writing this? HA tau divided by rho VC. Okay, so A by V I have substituted as 1 by LC. That 1 by L suffix C is 3.125. Okay, is it fine, ma?
Yes, sir.
Yes.
Okay.
Yes, sir.
Yes, sir.
Okay,
Yes,
ma.
sir.
Now find out tau. See, take natural log on both sides. You will be getting it easily. Students, hello?
Sir,
Yes, sir.
I'm getting
All of you are
1.
able to do this.
Yes,
If you
sir.
take natural log on
Yes,
both
sir.
sides, then what happens is okay. Now let me write it here. Natural log of how much it is? 108 minus 36.
So 0.2727, sir.
Tau.
No, sir. 108 minus 36 divided by 300 minus 36. That one. Sir, I got 154.72.
Yes,
One
sir.
minute.
Same, sir. Even I'm getting 154.
300 minus 36.
Yes,
That
sir.
will
I'm getting
be
154.9.
equal to this one minus 90 into tau divided by the denominator values 383 into 3.125 into 10 power minus 3. The whole thing will be coming in the denominator. So when you substitute it, you will be getting tau. What is the tau value you are getting?
154.7.
150.
So
154.72
72.
seconds. Okay. So first we got this. Okay. 1 minute. Hello. Am I audible?
Yes, sir.
Yes, sir.
Okay. The next one is instantaneous heat transfer. So the instantaneous heat transfer is eh, what is asked in the question? Instantaneous heat transfer at 108 degrees. Yeah.
Yes, sir.
Instantaneous heat transfer time required. Instantaneous heat rate at 108 degrees. Total heat rate and temperature. Okay. So instantaneous heat rate is the heat convected. Okay. HA del T. Instantaneous heat transfer. Kindly bear with me. I am writing in a soft surface. HA, sorry, Q equal to HA del T. Okay, and when we talk about the area, since it is a copper slab, okay, and it will be having some thickness, okay, and the heat will be transferred this surface as well as the other side, okay, and especially the thickness is negligible, so H into 2 into A into del T. Okay, so the H value, whatever it is mentioned here is
Nine,
how much my H?
nine,
90,
90.
90, 90. And what about the area? Area uh, 50 centimeter, 50 centimeter by 50 centimeter. So 2 into 50 into 10 power minus 2 and 50 into 10 power minus 2. So that is 10 power minus 4 area and del T, temperature difference. Now T minus T infinity. So what is the instantaneous heat rate at which temperature they are asking? At which temperature? 108 degrees, right? Am I
Yes,
correct
sir.
or not? So 108 minus what is the surrounding T infinity? 36 then.
36.
Okay. So 108 minus 36. So how much it comes? 108 minus 36 and how much?
3240 watt meter Kelvin.
3 2? It should be in watts
40.
alone because area will be
Sorry,
in meter
watts.
squared and temperature will be in Kelvin. Okay, and this one is watt per meter squared Kelvin. So meter
Yes, sir.
squared gets cancelled, Kelvin gets cancelled. So you will be getting only watts. How much watts?
3240.
All of you are getting it? All of you
Yes.
have taken down this,
Yes.
students?
Yes, sir.
Okay. Shall I move on to the third part, which is as?
Yes, sir.
Okay. Instantaneous heat rate, total heat flow rate. So the total heat flow up to 108 degrees, it will be change in energy. So MCP or rho V Cp into del T. Okay, change in energy of the solid from the initial temperature to the 108 degrees. Okay. So what is the initial temperature given? The initial temperature is 300 degrees C, right? So T naught, T naught minus or T minus T naught. So what is the next one? Total heat flow. Am I correct?
Yes, sir.
Total heat flow up to how much temperature? 108 degrees C. Am I correct?
Yes, sir.
So it is given by Qt, which is equal to the change in internal energy. Sorry, the change in energy of the particular solid. T minus T naught. So the initial temperature is 300, and instead of mass, let me write rho into V into Cp into T minus T naught. So what is the density? Some of them they said at the beginning.
8954.
Huh?
8954.
8954. And volume is 50 into 50 into the thickness. Am I correct?
Yes, sir.
Okay. So 50 into 10 power minus 2. Volume. All of you please note. V is volume. 50 into 10 power minus 2 into 50 into 10 power minus 2. And thickness is 6.25 mm, right?
Yes, sir.
10 power minus 3. Okay, so that is volume. Hmm? Now substitute that. Okay. And Cp value, what is the Cp value you said?
383.
So Q suffix T, which is equal to rho 8954 into this value. So 50 is 0.5 into 0.5 into 0.00625 volume into CP. CP value, what is the value, ma?
383.
383. CP, you are saying CP value only, right? Ah, okay. And what about T minus T naught? So the temperature, initial temperature is 300, and this one is 108, right? 108 minus 300. 300 or 360? What is the value?
300.
Yeah, 300. Okay. Now get me the answer. So it will be in joules. Okay, it won't be in watts. Because you have
There's a value negative.
yeah, heat is lost no from the solid. Density will be in kg per meter cube, volume will be in meter cube, CP will be in joule per kg Kelvin. Okay.
So
It's minus
negative.
Huh?
So negative
Yeah,
1.02 into 10 power 6 joules.
minus 1.02 into 10 power 6 joules. Okay, so the heat energy is lost. Okay, is it fine? All of you are getting this value?
Yes, sir.
Yes, sir.
Okay, and the last one is what is the temperature? What is the last thing which is asked? What is the temperature after 1 minute? So in this case, tau is given. The fourth one, I think that is the second one I have taken it at the last. Temperature after 1 minute. Okay, so if tau equal to 1 minute, that is 60 seconds. All of you please substitute seconds. Then what is T? T equal to what? Now T minus T infinity divided by T naught minus T infinity, which is equal to e power minus HA tau divided by rho Vc. So in this case, you have to find out temperature. We know T infinity is 36, T naught is 300. Okay, so substitute in the place of tau, substitute 60 and get me what is T after 1 minute. What is the value?
Sir, I'm getting 195.58, sir.
195.
Yes, sir.
Okay, what about others? Yes, what is the temperature? What about others, ma? All of you are doing or you are not doing it?
Trying, sir. Trying, sir.
Yeah. Substitute T minus 36 divided by 108 minus 36. Sorry, not 108, ma. 3. What is the initial temperature? 3 is 300,
3.
right?
Yes, sir.
Yeah. 300 minus 36. T minus 36 divided by 300 minus 36, which is equal to e power minus HA tau divided by rho Vc. What year? How much time you are taking? Only one problem per class. It's not a good thing, ma. Hello. Yes. What is the value you are getting? Fine. Please tell it faster.
So 195, I guess.
What about others? Only one or two fellows they are saying it. Ratan,
So 190, sir.
190. Saurav, Guru Nishant, Aditan,
Around 191.
191. Okay. So the temperature is 191 degrees C. Okay. Is it fine?
Yes, sir.
Okay. Is it okay, ma? Is it fine for everyone? All of you have taken?
Yes, sir. Clear, sir.
Okay, see the why I didn't substitute because the first thing we solved like this. The first thing they have given temperature as 408. What is the time taken? Here they have mentioned after 60 seconds. What is the temperature? Okay, okay, students. Is it
Yes.
fine? All of you have taken down. All
Yes,
of you
sir.
are having notebooks with you.
Yes, sir. Yes.
Yes, sir.
Okay, try the second one. I have not uploaded this, right? I will upload. Anyway, after the class, I will upload this also. I have uploaded the transit heat that is the interheat generation. Am I correct?
Yes, you have heard, sir.
Now the second one is sphere. Okay, so that's why I have given three problems. One is cylinder, one is sphere, and the other one is yeah, slab. So in the second case, you have a copper sphere. Okay, can you try this for some time, or I have to solve it again? What we have to do is since it is copper, you can use the same value. What is the value we have mentioned? Rho and other things. 89.
54, sir.
8954.
Okay. CP is 383. 8954 is the rho, right?
Yes, sir.
Rho is see for other materials you have to find it from the HMD data book. Please understand that. What is the density? 3854.
No, sir. 8954.
Sorry, 8954. Okay.
CP is 383.
CP is 383. And what about K?
386 watt per.
Watt per meter Kelvin. Okay, fine. So, uh, a solid sphere which is 10 centimeter in dia, initially it is at 250 degrees. It is suddenly immersed into uh, the fluid which is maintained at 50 degrees. If the H value is 200, determine the temperature of the copper block after 5 minutes. Okay, so tau which is equal to 5 minutes, 5 into 60, that is 300 seconds. Some of the students they will be substituting 5 minutes as it is. Okay, so time you have to substitute only in seconds. Okay, that particular thing you should know. Okay, now t minus t infinity by t naught minus t infinity, which is equal to e power minus ha divided by rho vc into tau. But this expression is valid only if Bayes number is less than 0.1. Okay, some of the students directly they will be taking this expression and they will be doing it. I won't give you full marks if even if the answer is correct. First, you have to check the Bayes number. Bayes number equal to h l suffix c divided by k. Okay, now characteristic length of sphere. So volume by area. So 4 by 3 pi r cube divided by 4 pi r squared. Okay, so that is r by 3. Am I correct?
Yes, sir.
Okay. Now L suffix C, which is equal to R by 3. What is the diameter given here? 10 centimeter dia. Okay. So radius is 5 centimeter. Okay. Radius divided by 3. 5 into 10 power minus 2 divided by 3. How much it is? 1.67. Am I correct? All of you
Yes, sir.
there?
Yes, sir.
Okay. Now find out Bayes number. What is the H value? It is given as 200. K value is 386. 200 into 1.67 into 10 power minus 2 divided by 386.
Yes, sir. 386.
Yeah. How much it comes?
8.65 into 10 power minus 3, sir.
Which is lesser than 0.1. Okay. See why we are checking Bayes number, ma? Let me recollect the theory. Why we are checking the Bayes number? Why it has to be less than 0.1?
To find out its systematic.
That is, the internal resistance, internal conductive resistance should be negligible when compared to the convective resistance. Okay. Or L by Ka divided by 1 by Ha. The 1 by Ha should be very much greater, whereas L by Ka should be negligible when compared to or so small. Okay. So if heating is occurring in that manner, then it is said to be Newton in heating. If cooling is done in that manner, then it is Newton in cooling. Is it fine? Is it
Yes,
fine?
sir.
Oh.
Yes, sir.
Now calculate. Now we know the expression Bayes number, which is sorry, not Bayes number. T minus T infinity by T naught minus T infinity, which is equal to e power minus HA tau divided by rho Vc, where A by V, which is equal to 1 by L suffix C. Okay, so that is 1 by R by 3 value which we got. So you can substitute. Is it fine? All of you are able to follow this?
Yes, sir.
That is the question. Okay, now initial temperature is T naught is 250 and T infinity is 50. Now substitute and get the result. What is the final temperature, ma? What is T infinity? What is T naught? All of you are able to understand or not?
300, I guess, T now.
Yes.
300. See, initial temperature is T naught. T naught is equal to 250 degrees C.
T infinity
Okay,
50.
T, not T, T infinity. Surrounding fluid temperature is 50 degrees. Carefully read the questions. Students, all of you are able to understand, or simply I'm doing this problem here.
Yes, sir, we understand.
See, you people, you are engineers, ma, and I am not the tutor. Please understand. Tell me T infinity 50, yeah.
Yes, sir.
Yes, sir.
What is T naught initial temperature?
250, sir.
250, sir.
250.
E power minus H. What is the H value given in the problem?
200, sir.
200. And in the place of A by V, I can substitute R by 1 by R by 3. Okay. So 200 into after how many minutes they are asking?
5 minutes.
5 minutes.
5 minutes, sir.
5 minutes. So 5 into 60, that is 300 seconds. 300 seconds divided by rho VC. Now tell me rho value and 1 by RC value and 1 by LC value.
8954 sir, low value.
8954 into 1 by what is that value? 1.67.
1.67 into 10 power minus 2.
10 power minus
2 sir.
2. 10 power minus 2 and into CVS 3.
83 sir.
383. Okay. Now find out this. What is the temperature?
So I'm
Find out the temp.
0.19
Huh?
sir. 120.19.
20.
120 sir. 120 degrees C.
120 degrees C. All of you, please check. Yes, all of you are getting it or some other answer? Hello.
So I'm also getting.
120 degrees C, is this fine?
Yes, sir.
Everyone, all of you are getting it?
Yes, sir.
Yes, sir.
Okay, ma. Now what I will do is I will copy the third one. Okay, you have to try this and you have to tell me the answer in the next class.
Fine, sir.
Add box. So try to use the same principle. It is a cylinder. Okay, students,
Yes, sir.
it is a cylinder. Okay, so cylinder, you know that yeah, volume and area you should know, right? What is the volume? Volume is pi r square into L, right? And area is 2 pi r L. Am I correct? Surface area.
Yes, sir.
Okay, so r by 2, radius divided by 2 will be the uh, characteristic length for the cylinder. Is it fine? All of you, can you do it in the next class? Sorry,
Yes,
Yes.
can you say the answer in the next class on Monday?
Yes, sir.
Yes, sir. Will do, sir.
Okay, ma. Let me stop the recording and let me download the attendance.